Okay, so one of the things we talked about the other day was how to build equations and how to build expressions. And we are going to expand on that today, and we're going to talk about how to solve them, okay? One of the things we looked at was how to identify equations versus a expression. And if you look at this, these are exactly the same except for one major difference, and that is right here. Because this has the equal part, the equal sign, and an actual solution, you're required to do something. And if you're required to do something to it, if you're required to solve anything, this is an equation, okay? And remember we said it's pretty outside. It's a beautiful day. There's nothing that you're required to do with that, so that is an expression. So an expression and an equation, the difference is that equal sign. An equation has the equal sign, the expression does not, okay? All right, so to solve, a lot of times you will see an equation that looks like this, or you'll see it with a letter. I know just by looking at this, if I'm using my big brain, as you guys like to say, 5 plus something is 20. Well, if I think about it, I know that I can add 15 to 5 and get 20. Well, how did you do that? If you didn't add, how did you really do that? Well, we actually subtracted. You subtract 5 from 20, and that's how you got your 15. And you'll notice they match up. Okay, we can do that in our head, but there's a mathematical or algebraic way to do that, and that's what we're going to look at. Okay, so we did a addition. Let's look at a subtraction. What minus 6 gives you 20? Well, if I'm subtracting 6 and my ultimate goal is 20, that must mean my original number was 26. And I know that because I can just add it to it and get 26, right? Well, that's pretty much exactly how you do a solution to an equation. You do the opposite of what it says that you are doing to find it, okay? So for this example, something plus 8 gives you 20. Well, 8 and what will give me 20? All right, so to do it, there's a couple different ways. We're going to talk about it algebraically, okay? If you can do it in your head, fantastic. But the more you do it in your head, the less likely you are to get it right when it gets a little bit more difficult, okay? So one of the things we like to do is we're going to tell a little bit of a story. So in our story, we have this bridge right here is our equal sign, and I am going to draw a river that's going to run underneath my bridge, okay, or on top of it in this part. Okay, so my bridge is running and there is a troll on top of my bridge and I have to pay the toll to my troll, okay? And my goal is to ultimately get my X where it's all by itself, and that's called isolating the X. So to pay the toll, I need to get rid of the 8, but to pay the toll, I have to pay the toll, right? I know that sounded stupid. To isolate it, I got to get rid of that 8. How do I get rid of a positive 8? I subtract 8, okay? Because I know 8 minus 8 gives me 0. So these two 8s cancel each other out. Well, when I pay the toll and I go across that bridge, it's going to be the exact same thing on the other side. And so I know 20 minus 8 will give me whatever my solution is. So let's subtract. I'm going to borrow from the 2. I'm going to make that the 10. 8 from 10 is 2 with a 1 in the tens place. So X must be 12. Okay, so I'm going to check my work. By checking it, I'm going to take my 12 and put it back into the original equation and replace the X with the 12. Okay, so I'm going to go in here and I'm going to say 12 plus 8 equals 20. Well, 12 plus 8 is 20. Does 20 equal 20? Why, yes, it sure does. So I am good. Okay, so that's addition. Now we're going to do subtraction. Remember, we're going to do the opposite operation. So I'm going to draw my river, and I'm going to pay the toll. If I'm subtracting, I'm going to do the opposite of subtraction, which is addition. And if I go to one side of the equal sign, I go to the other side of the equal sign. My 3's cancel each other out because that turns into 0. 7 plus 3 is 10. So I know my solution must be x equals 10. And again, I can take it, put it back into the equation, see if my math is correct. So, oops. 10 minus 3 is 7. That is 7 equals 7. Is that correct? Yes, it is. Okay, you can continue to do these no matter what the numbers are. Draw your line, do the opposite operation, pay the toll, going across. X is equal to 7 from 15 is 8. So in this situation, x is equal to 8. Remember to always box your solution. That way you can tell what your answer is, and then when you plug it back in, you can find it easier. So x plus 7 is 15. 15 equals 15. I am good to go. All right? So it again doesn't matter if I'm adding or subtracting, but what happens if I'm dividing? It actually is the exact same thing. I'm going to draw my line. I'm going to pay the toll by doing the opposite operation. Well, what's the opposite of multiply? Divide. So I'm going to divide by 5, and I know 5 divided by 5 is just 1. So I'm left with 1x on this side. If I've gone to do it to one side, I have to pay the toll and do it to the other side. 75 divided by 5. Well, if I can't do that in my head, I'm just going to come over here to the side and write it out. And I know 5 goes into 7 once. 5, subtract that out, get 2, drop my 5. 5 goes into 25 5 times, evenly with no remainder. So my 1x must be equal to 15. So there's my equation, there's my solution. And again, I can plug that in. 5 times 15 equals 75. I can check that. I can check that right back up here like we did here. Do the math. 75 equals 75. Yes, I am good to go. Okay? So division, multiplication, you do the opposite, which is division, which must mean if I'm going to divide, I'm going to do the opposite, which is multiply. Well, because of the way this program works, I can't really show it as a fraction, but the majority of the time you will see it as a fraction. So it'll look like this, x over 2 equals 8. Okay, well, and I know the opposite of division is multiplication. So again, draw my line. I've got x over 2. I'm going to multiply by 2. And when I do, that ends up with 1 as well, because 2 divided by 2 is 1. And I've got 8, and I'm going to, multiply 8 by 2. And 8 times 2 is 16. And I never finished that x. That's funny. Sorry about that. That's the x. Okay? 8 times 2 is 16. All right? If again I take it and plug it back into the equation, it would be x over 2 equals 8. I'm going to take and plug in the x value. So it would be 16 over 2 equals 8, and I know half of 16 is 8, so 8 does indeed equal 8. Okay? And again, you can continue to do these, doesn't matter what the numbers are. You're going to do the inverse operation. Okay? So if I have addition, I'm going to do subtraction. If I've got subtraction, I'm going to add. If I've got multiplication, if I'm multiplying, I will divide. And if I'm dividing, I will multiply. Okay, I do the opposite of what it says. All right, I hope that makes sense. Yell at me if you have any questions.